I'm going to spend a little bit of time talking about publications in the Federal Aviation Regulations. Now, when we talk about publications, what we're really talking about are the documents and documentation that we use in order to maintain aircraft appropriately. So let's take a look at what this means and take a look at a couple important pieces of documentation that you'll be using. First, we're going to talk about acceptable data. We'll talk about instructions for continued airworthiness and some of the pieces of documentation or publications that fall into that category. We'll talk a little bit about inspections and what the level of detail is on those. We'll talk about special airworthiness information bulletins, technical standard orders, parts manufacturer approvals, and using airworthiness directives. So let's dive right into acceptable data. Acceptable data is something that we can use for maintenance procedures. This includes everything we might do on an aircraft that is not a major repair or major alteration. As we'll talk about in the forms video, a major repair or major alteration, as defined by 14 CFR Part 43 Appendix A, is something that goes beyond the scope of normal maintenance and will require additional approving engineering data in order to determine whether or not that repair is legal. It also must be submitted to the FAA for approval as a repair or alteration. But anything other than major repairs or alterations is covered under what we call acceptable data. So what's within this acceptable data subset? Well, we have a few different sources. We have things that are supplied by the manufacturer, which comes in the form of maintenance manuals, aircraft flight manuals, pilot operating handbooks, structural repair manuals, illustrated parts catalogs, and component maintenance manuals. Those are our best sources of data when we're looking for acceptable data. While it is still acceptable, it is considered a secondary source. We have the FAA's supplied data through our AC 4313-1B and 2A. So moving on to manufacturer supplied data. What do we have involved in that? These are our instructions for continued airworthiness. Now, this is kind of a tricky term because not every aircraft necessarily contains instructions for continued airworthiness, but the concept is anything that the manufacturer supplies that allows us to maintain the aircraft in an airworthy state in ongoing operation is considered instructions for continued airworthiness. This can include things like maintenance manuals. Maintenance manuals are going to be our primary source when we're looking for information that we need to complete a repair or a maintenance operation. This is approved data that the manufacturer has submitted to the FAA, and it makes a big difference. This is really tailored to the aircraft we're working on. Where some FAA-provided information may be somewhat generic, the maintenance manual will speak directly to the aircraft that we're working on, as well as providing some very specific references that are required from the FAA, like troubleshooting and certain inspections that will allow us to maintain the aircraft in an airworthy state. We have airworthiness limitations, and this really focuses more on the operating side of things. So we have the Aircraft Flight Manual and Pilot's Operating Handbook. This can detail things like speeds, never exceed speeds, maneuverability speeds, things like that for the airframe. It may include different loading information, different information for weight and balance on the aircraft, performance charts for how the aircraft engine should perform at different RPMs, different propeller settings, and different altitudes. These really pertain to all of the operational characteristics of the aircraft and can be used to create benchmarks or seek information on whether or not the aircraft still conforms to its airworthy condition. We also have service bulletins and instructions. Service bulletins and instructions are usually brought out by a manufacturer when a problem is discovered in the design. So it may be something that the manufacturer missed, it may be something that the FAA missed as well, or it could simply be something that didn't act the way that was expected. Maybe we have a bracket behind the avionics panel that wears out more quickly than it should have otherwise. If that's the case, we could see a service bulletin or instruction be released by the manufacturer that indicates that there should either be an inspection of that particular bracket that takes place at a certain number of hours and intervals, or it may recommend the replacement of that bracket with a new type. It's not necessarily something that affects safety of flight like we would see with an airworthiness directive, but it does offer information for how to better maintain the aircraft over time in an airworthy state. The other three that we have are additional information that helps us understand how to repair or maintain the aircraft. The first is our structural repair manuals. Structural repair manuals are very effective because they help us to determine if a proposed repair is going to work or not. It can be from something as simple as stopping a crack that's developed on a particular section of the aircraft to making a small patch for a dent or damage that's occurred to the airframe. It could go as far as completely rebuilding a section of a wing after it's been removed from the aircraft. That's the kind of information we can find in our SRM. It'll differ from what you see in small aircraft versus larger aircraft. Larger aircraft will tend to have a separate SRM for the aircraft, whereas many smaller aircraft will have an SRM incorporated into the primary maintenance manual. Another document that we use quite frequently is the Illustrated Parts Catalog. The Illustrated Parts Catalog is useful because it shows us all of the components of the aircraft broken out into an exploded view that allows us to identify parts. This is useful for reordering parts, for checking conformity. If we remove a bolt, we aren't sure if that's the bolt that should have been there originally. We can cross-reference that in the Illustrated Parts Catalog and gain a better understanding of how that entire system should look when it's assembled. We use this quite frequently going through inspections as well as regular maintenance procedures if we have to replace parts or if we need to identify a new part for replacement. The last is our component maintenance manuals. Component maintenance manuals are a little bit different because they cover small components that are not necessarily considered a part of the aircraft. And what I mean by that is if we have a Piper aircraft with a Lycoming engine, we could have components on that engine, different models of vacuum pump, different models of starter. Those are not going to be under Piper's maintenance manual. We may have information for installation and removal, but we may not have any information specific to the repair and operation of that particular component, and that's where our component maintenance manuals come in. One of the ones you'll become familiar with next quarter when you get into power plant and start working with ignition are Magneto maintenance manuals. Those are considered component maintenance manuals that focus on a specific element of an aircraft design that is not necessarily covered by the aircraft manufacturer. One thing I should point out as well with maintenance manuals, the maintenance manuals that we see with smaller aircraft tend to be produced solely by the manufacturer. In some cases, with Part 121 or Part 135 operations in the commercial range, we may see maintenance programs that are developed by an airline. So, for instance, Alaska Airlines may have their own approved maintenance program for the 737-800 that has been approved by the FAA. So they've effectively written their own manual of procedures and operations for maintaining the aircraft. They've submitted it to the FAA. The FAA has deemed it appropriate and safe. And now that is a maintenance manual specific to Alaska Airlines that can be used working only on Alaska Airlines aircraft. You cannot work for, let's say, United and then use an Alaska Airlines maintenance manual for use on United aircraft. It is specific to that particular operator under Parts 121 or 135. Something else that's very helpful to understand when we're looking at maintenance manuals is the ATA 100 system. There's a lot of information that is contained within maintenance manuals, and historically, especially with smaller civil aircraft, we've seen a lot of different formats and design of maintenance manual, which can get very confusing when you're trying to seek information. Something that's used to solve that is the ATA 100 system, which assigns a standardized format for the location of content within manuals. You see this used very, very heavily within commercial aviation. If you're looking at Boeing manuals, a lot of larger commercial operations, you'll see them organized in this ATA format. Even newer civil aircraft manuals are starting to comply with this ATA format. It is not necessarily a regulatory piece, but it is very, very helpful. However, when you start getting into older manuals, you tend to see the ATA format less and less, which makes it a little more difficult. It's a long list. It can be difficult to memorize. However, there's different ways. You can print yourself out a copy and keep in a manual that you use frequently. I've even seen some students print out a small copy and slide it right inside their badge holder so they have a reference to be able to go back to. It can be very, very helpful to locate information quickly. The downside is when we use electronic records to try to look up manuals, they can be helpful, but oftentimes we rely on the search function far too much. People like to hit Control F and then type in the word they're looking for, and that usually presents problems, either in the fact that the particular document they're searching may not be coded to recognize text. It may be that the term they're searching for is not the specific term that the manufacturer uses when addressing a specific topic. So they may feel like they haven't found any information, where the manufacturer may go into great detail but just using different terms than were expected. So understanding where information is located and how to locate it using a table of contents or the ATA system is going to be very, very helpful as you start looking at more information with aircraft. The second piece we have is our FAA Supply Data. Now this is also considered something that could be an instruction for continued airworthiness because it outlines our acceptable methods and practices for maintenance and alterations. But again, this is not our best source, this is simply an acceptable source. We can cite it if need be, but it's not our primary resource we use if we have something from the manufacturer. Let's talk a little bit now about inspections. We introduced the concept of 3 primary inspections that are required under Part 91. We have our annual and 100-hour inspection and our progressive inspection. Now, as you'll remember, a A&P mechanic cannot perform and return to service an annual inspection nor a progressive inspection. However, an A&P mechanic without an inspection authorization can approve for return to service a 100-hour inspection. I've grouped these together because the annual and 100-hour inspections are effectively the same disposition or the same list of items that must be inspected. The progressive inspection, however, can vary because it is independently negotiated. So let's take a look. Annual and 100 hours are described in the manufacturer's instructions for continued airworthiness. In most cases, this will be in the form of the maintenance manual. Many aircraft provide a list of inspection items to be used for either a 100-hour or annual inspection. If for some reason a manufacturer has not provided that information, our next best resource is the 14 CFR Part 43.13, Appendix D. Appendix D defines the scope and detail required for an annual or 100-hour inspection. The difference is an annual inspection is performed once per year, while a 100-hour inspection is performed, you guessed it, every 100 hours. The one key with a 100-hour inspection is there is a little bit of slack that's allowed. A 100-hour inspection is allowed to go in approximately 10 hours of extra time if it is required to get the aircraft to a base where the inspection can be performed. If it goes outside of that period of time, the aircraft is no longer considered airworthy as it is now out of its current inspection. Similarly, with an annual inspection, that is an inspection that takes place every 12 months. It must be performed by a mechanic holding an inspection authorization. And again, it must address all of those items that are either in the manufacturer's ICA or the 4313 Appendix D. That again happens every 12 months. If we go outside of 12 months, the aircraft cannot exercise its airworthiness certificate because it has not met that requirement of Part 91 and is in violation. Progressive inspections, on the other hand, are described in 14 CFR 91.409. Progressive inspections are different because rather than pulling the aircraft out of service for a specific period of time during certain intervals, a progressive inspection is allowed to take place while the aircraft is remaining in service. This progressive inspection system is going to be developed by whoever is owning or operating the aircraft, and it is going to be submitted to the FAA for approval. So effectively, with a progressive inspection, you get to create your own inspection procedures, but then it must be submitted to the FAA for approval. If the FAA approves your method of inspection, then you can use that as your basis for signing off a progressive inspection, which again is not something that a A&P without an inspection authorization can perform. Another piece of information I'd like to talk about is our Special Airworthiness Information Bulletins, or SAIBs for short. This is a familiar concept because, like service bulletins that we see through manufacturers, a SAIB is going to address a defect or an issue with an aircraft that is not necessarily a safety of flight issue. The easy way to think about this is that SAIBs are basically the same concept as an airworthiness directive. They've been issued by the FAA, however, they have not been deemed severe enough to require an airworthiness directive. So as a result, these SAIBs are not mandatory, nor are they regulatory. They are simply strongly recommended to be performed to maintain the aircraft in an airworthy state. On to parts manufacturing. There's a couple things we need to understand about parts used in aviation. First of all, because we have type certificates that cover the aircraft being built, we have to have some way of establishing what are approved materials to use in repairing an aircraft. You'll notice that 14 CFR Part 43.13 addresses specifically the materials being used. It doesn't call things out by name necessarily, but it does say that they have to meet a quality or standard of the original component installed. We have a lot of different pieces, for lack of a better word, that go into an airplane. When we talk about technical standard orders, technical standard orders, or TSOs, establish the minimum performance standards for components on certificated aircraft, or an aircraft that is covered under a type certificate. This can range from anything from seat belts to safety restraints to life preservers and things of that nature. A manufacturer can apply to use a technical standard order when producing components for their aircraft. On the other hand, a parts manufacturer approval, or PMA, is something that the FAA will approve upon application that allows a person or manufacturer to produce modified or replacement parts for installation on a certificated product. This differs slightly from what we would see with a supplemental type certificate because we aren't altering the design of the aircraft. With a supplemental type certificate, this may include installing parts on the aircraft that may be covered under a PMA, but are used to change the fundamental design, like adding winglets onto an aircraft for short takeoff and landing. Regular PMA'd items can be used to replace the original items that were installed. So if Continental shipped an engine with a specific brand of spark plugs, there's a number of choices we have, either through Champion, Tempest, Unison, all these other companies that are manufacturing the same type of spark plug under this PMA. They're used as replacement parts. We can kind of think of it as aftermarket parts as opposed to the original manufacturer parts, or OEM, if you're thinking in automotive terms. One other thing I'd like to show you here that we talked about in our key points is how we use airworthiness directives. So as we take a look to an airworthiness directive that is listed here, I've pulled up an AD for the Piper PA28-181. I want to show you a little bit about what we see in airworthiness directives and also give you an idea for how we can read these and establish what we need to do with them. So with most modern airworthiness directives, they will come in a format where we have a header, we have a preamble that describes a couple different things. In this preamble, we see the agency that approved it. This is obviously the Federal Aviation Administration. The action, this is an active airworthiness directive that went through the comment period, so it is a final rule. We have a summary that talks about what this AD is for. Jumping to the business end of it, it tells us that this is in response to reports of worn flap handle attach bolts and elongated holes in the flap lever to the cable mounting attach point. Effectively, there was most likely an aircraft that crashed with fatalities involved due to worn attach bolts and elongated holes in the flap lever. Therefore, an AD has been designated to inspect or correct this deficiency. We have an effectivity date, which is June 14th, 1996. We have the addresses for service information that applies to the AD, so we can obtain additional information from the Piper Aircraft Company. We also have supplementary information. This covers things like what comments were presented back during the commenting period. If people felt like it was a hardship, if people had additional information or felt that the AD did not completely cover the unsafe area, they had the ability to make those comments, and some of those comments have been included in the supplementary information. This is all identifying the airworthiness directive, what it's for, and who is involved. The part that's really important to us comes later in our regulatory information. Here we see our AD number, 96-10-03. That tells us it was in 1996 in the 10th biweekly period of 96, and it was the third AD that came out in that biweekly period. It is pertinent to the new Piper Aircraft Corporation, and we see applicability. This applicability portion is very, very important because when ADs are released, they are often released for a series of aircraft. We're going to get identification through two means. We'll have identification of the aircraft model, as well as identification for a specific run of aircraft designated by the serial numbers. So in this case, I told you we were looking at a PA28-181. So as I scroll this to the top, we see that our model affected is the PA28-181, and it is applicable for serial numbers 28-769-0001 through 28-869-0062 and 289-0001 through 289-0169. Those are the affected serial numbers for this model of aircraft. If I was checking to see if this was pertinent to an aircraft I was working on, then I would see if my model is included. In this case, if I'm working on a PA28-181, it is. And then I'm going to check the serial number on my aircraft to see if it falls between these serial numbers that are indicated. If my aircraft falls outside these serial numbers, the AD does not apply to me. I do not need to comply with this for the aircraft to be maintained in an airworthy condition. However, if the serial number does fall within these ranges, I must perform the work on the AD. This is important because the primary responsibility for this is assigned to the owner or operator. However, whenever a mechanic is performing an annual or 100-hour inspection, they are required to check for and comply with as necessary these airworthiness directives, or at least in this case, we have to check for and establish that the AD must be complied with and included in a list of discrepancies for the owner or operator. That is where our responsibility comes in this whole menagerie of legalese. As we move down, we're going to see a couple notes that are included that have additional information that is pertinent to this AD. Note 1 tells us that this is applicable to each airplane identified in the applicability section, which we just took a look at, regardless of whether it has been modified, altered, or repaired in the area subject to the requirements of the AD. Therefore, if we've just made a repair to the flap system because we noticed these elongated holes and we submitted the paperwork, just because we performed that repair does not mean that this is going to be the continued approved method for continued airworthiness. Therefore, even if we just repaired this yesterday and the aircraft hasn't flown yet, in order to conform with this AD, we're going to have to comply with the repairs that are cited in this airworthiness directive. Note 2 tells us that the time specified in this AD takes precedence over the time specified in the service bulletin that Piper released. So here we see a situation where a service bulletin came from Piper Aircraft, and it eventually became serious enough that it was turned into an airworthiness directive. It also tells us that the instructions in this AD are different from the Piper service bulletin, and the instructions take precedence. So basically we must follow the regulatory AD instead. Below this, we see the work laid out for compliance. To prevent failure of the flap handle attachment and sudden retraction of the flaps, which if not detected and corrected could result in loss of control of the airplane, accomplish the following. And we are given a set of paragraphs, A through F, that tell us how we can comply with this. E tells us that we can obtain a special flight permit, so something like a ferry permit, if we are not in a position where we can make the repairs. So if the airplane would otherwise be grounded because of the compliance time or something like that, but we do not have a facility available that can perform the AD, we can apply for a special flight permit to take the aircraft to a location where the work can be completed. Paragraph F tells us that an alternative method of compliance or adjustment of the compliance time that gives an equivalent level of safety can be approved by the manager, in this case for the FAA, at the Atlanta Aircraft Certification Office. So effectively, if this doesn't work for you, if it is going to inhibit your operations in such a way that you feel it's necessary to apply for an alternative method of compliance, you're welcome to. Now, the caveat to this is it's not always particularly successful with the FAA and requires a lot of work. In most cases, it is just easier to comply with the Airworthiness Directive as written. Further down, we get a little more information in Note 4 that tells us for where more information concerning the approved alternative methods of compliance can be found. The part I want to cycle back to, though, is up here in Note 1 that tells us when this must be complied with. So Note 1 tells us the outline of the AD. Underneath that, before we reach Note 2, it notes compliance. This tells us that compliance is required upon the accumulation of 2,000 hours of time in service or within the next 100 hours time in service after the effective date of this AD, whichever occurs later unless already accomplished. To translate this for you, effectively the AD tells us that when the aircraft reaches 2,000 hours of time in service or within the next 100 hours after the AD has been released, whichever occurs later, is the time it must be accomplished by. So, if the aircraft does not yet have 2,000 hours time in service, then we don't have to comply with it yet. It tells us that it must be within the next 100 hours time in service after the effective date, whichever occurs later. So, if we have an aircraft that has 1,000 hours of time in service, we can wait until 2,000 hours because that occurs after the next 100. However, if we have an aircraft that has already accumulated 2,000 hours time in service, we do not have to drop everything and perform this AD. However, it must be performed within the next 100 hours of time in service. That's how we read our compliance date. That is one of the most important things that we can gather from an airworthiness directive, is determining if it's applicable to our aircraft and, if so, when it needs to be complied with. Those two sections, if you can understand how that functions, will help you out greatly. That covers everything we have for publications. I hope you've enjoyed what we've taken a look at. If you have any questions, as always, please send me a message and I'll help you if I can.